Hello everyone. In this video I am going to discuss about the Kubernetes. What exactly the Kubernetes? See, Kubernetes is a container orchestration platform. Before discussing about these things, we need to discuss what exactly the drawbacks of the container so that we are introduced with the container orchestration. See, the containers what you are running provides a system environment. That's all. They make your container make your application to run, and they want your application to stop, remove. We can able to do a lot of things with a container. But the thing is that these containers will not be used directly on the production environment. Production is something where your user is actually using your application. The Docker or any sort of a container will actually run smoothly until and unless your virtual machine is providing efficient resources to uh, you know your Docker or any sort of container. The time when your virtual machine removes some resources out of your Docker or any sort of a container, your container goes down or it will die. The time it will die, then your user base who is using your application will not be able to access your application and will face huge losses over there. Therefore, containers are never directly used uh, into a production environment. Rather than, you will provide some orchestration platform that manages all of your container, and Kubernetes is one of them. There are a lot of alternatives to the Kubernetes, and there are a lot of distributed version of the Kubernetes what we are using. First and foremost thing, what exactly Kubernetes solves or container orchestration platform solves? The first and foremost thing is that it will provide a cluster. um, it will provide a cluster. What exactly the cluster? See, in the Kubernetes it will provide some master node that actually manages all your child nodes or the worker nodes. If any worker node is not efficient or it is not capable of handling anything, in such case it will make some sort of a connection and it will say, okay, it is not working, I need to create the new one. And this is actually how it does. Kubernetes has a lot of capabilities. The first and foremost is auto scaling and auto healing. Normally, I will show you over here what exactly happens. See, this is the application. This is the application, and this is actually a pod. Let's consider it as a pod. Um, let's consider it as a child node. This child node has a lot of things like a kube proxy, kubelet as lot. Under that we have something called as the container runtime. This is the container runtime. This is the actually container runtime, and I just change the color. Okay, this is the container runtime, and under this container runtime we have something called as pods. We have something called as pods. This is the first pod, and this is the second pod. This is the third pod. I just increase this size. This is the fourth pod. See, we have 4 pods that are running inside the child node. You have master node, you have child node. Under the child node you have the container runtime. Under the container runtime you have the pods, and inside pods you have the container. And actually pods are they schedule your containers, like whether your container should be running or not running. It is decided by the pods. And here you have the pods 1 2 3 4 pods. See, and what happens, the time when some container dies, the time when this particular uh, pod dies, what exactly Kubernetes does, that it is always monitoring your pods. The time when it dies, before dying itself it create a new one. It will create and associate a new pod here, and this is termed as a auto healing. Here you have 4 pods. If eventually one pod dies or it become unable to access it is not accessible. In such case, one if it dies, eventually in parallel format only it creates a new pod, so that there will be zero downtime. Your application will be running smoothly without any disturbance. This is how actually the auto healing works. And what is exactly auto scaling? See, you have dedicated, see, this is your application. This is this is the first app, this is the second app, and this is the third app, and this is the fourth app. This is the fourth app. And what exactly I do, see, this is the fourth app. These are the four applications that are running inside your pod. These are the pod itself. Under the pod you have the application. And what happens, you have dedicated 100 users to each of the pod. Like there comes totally 400 users. The first 100 users goes to first app, second 100 users goes to second app, third 100 users go to third app, fourth 100 users go to fourth app. 400 people completed. Now the traffic has increased. Now you are getting 500. Now you are getting 500 users. In such case, Kubernetes, what it exactly does is that it will increase the pod count to 5. It will increase the pod count to 5. Means if you have created your application and that can able to run smoothly with 100 users, what Kubernetes does, that if there is an increase in traffic count by 100, like previously you have 400, therefore 4 pods are running. If the traffic is increased to 500, then there will be 5 pods that are running. This is termed as auto scaling. It will scale up eventually, and this is how it is more efficient. And it has something called as a fault tolerance. Means you have these all the applications, and if you are making any change with this particular application, the fifth application, the 4 pods will be running smoothly. They don't have any of the hindrance. This is called as a fault tolerance. Means, and whatever changes you are making with other containers, other application, the rest of will not be affected. This is termed as a fault tolerance. Your fault tolerance, auto scaling, auto healing, and this is a secured one. You will come up with a lot of security related to this Kubernetes. Therefore it is one of the secured one. And you can able to do the configuration management using the Terraform and Ansible. And these are the capabilities. These are the actually capabilities. And you can able to make load balancing. As I previously discussed, if any of the pod dies or there is increase in the traffic, it will eventually make a new pod and just redirect the traffic to the new one. This is capability of the Kubernetes. It could able to do a lot of things. Therefore the container orchestration become a major event in the industries, in the DevOps. And why the actually container orchestration is used? First one is a fault tolerance, the second one is auto healing, auto scaling, load balancing, service discovery, and it has a firewall configuration. Therefore you can able to make a production ready applications using this Kubernetes or the container orchestration. Therefore it is used. Okay, let's discuss more thing about the monolithic and micro architecture. See, normally when you're building any sort of application, what you do, just consider this as a front-end application. This is a front-end application that you are running inside one container. This is the back-end inside, you are running inside one container, and this is the database services that you are using inside one container, and all the containers are different. This is called as a microservice architecture. Means if you make any changes with this thing, you can only do changes with this particular container. If it is a backend, like just have to mention the name so that it will not create any. This is a front end, this is the backend container, and this is the database container. See, you have 3 containers that are running, and if you want to make any changes with the backend, then backend will not be disturbed, like the front end and database will not be disturbed. Making changes in database, front end and backend will not be disturbed. This is the actually configuration. This is the architecture. Everything is done. Now there is something called as a monolithic. If I deploy everything in one thing only, like just cancel these all the things. This is the front end, and this is the back end. This is the database. Everything in one place. This is termed as a monolithic architecture. This is not the efficient one, because if you want to change anything in the back end, then you have to disturb both front end and the database. Any changes in database could eventually affect the front end and back end itself. Therefore, it is not preferred. This is a monolithic architecture. In the microservice, you are allocating every container a different one. Like for a front end, there is separate container, back end separate container, database separate container, and login, logout. Everything is in separate format. You are dividing your application into chunks. That is called as a microservice. Normally in the Kubernetes we use microservice architecture because you are managing multiple nodes. Therefore it is efficient over there to do this all the things. And I just remove this thing, and I'll just go over here, and I just type the Kubernetes architecture. It is not that complicated one. Normally you have kubectl that is connecting with your container plane. Container plane is connecting with your data plane. Container plane has something called as the API server that is taking requests from the kubectl, and you have etcd that is something that has information about the clusters, and you have the scheduler that schedules your pods, and you have controller manager that is actually making your pods into a desired state, and you have the kubelet that is actually making the pods running. If it is not running, it will give it to scheduler to schedule it, and you have the kube proxy that is something related to a networking, and after that you have the container runtime that has the pods and container that are running. Therefore, to explain this in very simple manner, okay, I'll take this example. Is it fine? Okay, this is fine. This one is a fine. See, this is the Kubernetes network. First of all, we have something called as a kubectl. Kubectl is actually command line interface. It is a command line interface through which you will guide your application to how it has to create some services. For example, if you want to get the information about the pods, kubectl get pods. If you want to get information about your nodes, kubectl get nodes. If you want to get information about your deploy, kubectl get deploy. If you want to get information about replica set, kubectl get replica set. If you want to get information about the services, kubectl get services. This is how easy it is. When you make any of the command, like if you make any command, if you write any sort of a command, this you write using the kubectl, and kubectl get pods, kubectl get nodes, and the kubectl it is making the request to this API server that is present in the control plane. API server is actually managing everything. API server is connected to the scheduler, API server is connected to the controller manager, API server is connected to the etcd. What is exactly etcd? See, all of the information about this is whole cluster. This is a control plane plus these worker nodes constitute a cluster, and these clusters are the information about this cluster is stored in etcd. If the etcds get deleted, then whole of the information that your container having is get deleted. It's one of the most important thing. And you have something called as a scheduler. Scheduler actually schedules your pods, whether your pods are running or not. It will just monitor it. If it's not running, it will schedule it. And the controller manager. See, pods have containers. It will check whether pods are running or not by scheduler part. Controller are the object that make sure your pods are running. Scheduler is only monitoring it, and after that it will tell to the controller that okay, these pods are not running, you have to make it to run. First of all, when containers like pods are introduced, we have something called as a current state, desired state and ready state. If the desired state says that there must be 5 pods running, and here in the current state, if there are 2 pods running, then your ready state will be 0. The time in current state, like there must be 5 pods running, and 5 pods are actually running in the current state and desired state, then your ready state will be 1. And this information, like the controller is actually managing the pods. They are making sure everything is scheduled properly, like every pods are running properly. It is actually managed by the controller. Then who is managing the controller? The controller manager is managing the controllers. There are a lot of controllers that are managing a lot of pods inside your cluster, and those controllers are managed by your controller. The controller managing the pods, whether they are running properly or not. Who is managing your controller? That it is through the controller manager. And after this thing, you have this thing like the worker node. They have mentioned it as a worker node, but these are termed as a data plane. And in these all things, first you have the kubelet. What is exactly kubelet? Kubelet always monitors. See, here inside the worker node or inside the data plane, kubelet is monitoring the pods, whether pods are running or not. And if the pods are dying, if they are not working properly, then kubelet will directly inform to the scheduler. See, scheduler, the pods are not running, you have to take care of it. Scheduler sends request to the controller manager. It says the controller manager, it is not working, you have to make it work. And the controller manager has a controller that will increase the pods to the current state to desired state. And we have the kube proxy. Kube proxy is normally related to networking. It makes sure that this particular worker node can able to communicate with other worker node. The pods that are running inside it can able to communicate with the pods outside it, and outside the worker node also. And kube proxy also take care that this particular worker node will be able to connect with the control plane and all of, like, if there were a person who is outside this cluster, like there is a huge organization and people outside the clusters want to make a request with this worker node inside a cluster, they could able to make it. That is make sure by the kube proxy, and it will also provide the IP addresses for the worker nodes. And after that, you have the container runtime. This is the container runtime, and inside the container runtime you have the pods, and inside the pods you have the container. These are the pods that are inside the container runtime, and inside the pods you have the containers. And here you are inside the container, like containers are normally Docker files or something else, and these are actually running inside. See how complex it is. If you directly create with a Docker, then you cannot able to manage such complex infrastructure. Kubernetes is providing these all the things. And Kubernetes is actually built by Google, and it was open source in 2014 because Google handed over this huge complex process to the CNCF, the Cloud Native Computing Foundation, and it is an open source one. Means using this particular code you can able to make any of the changes. There are a lot of such open source that is present in the GitHub, where you can able to contribute, make your code in multiple users system. And here the Kubernetes is not only the one project that is CNCF is managing. It is managing a lot of projects. The first one is Linux. Linux is a system, like operating system. You have a lot of distributed one, and this is all about it. And the Kubernetes, the something new about Kubernetes is that Kubernetes, no one used it directly into the production version. You have something called as development and the production. Development, where actually developers are doing a lot of things, testing things, and there is something called as production version, where actually users are using your application. And Kubernetes is not directly used for the production version, because Why exactly it is not user? Um, okay, I will just go through it. Why exactly it is not user? Because no one is actually managing the Kubernetes. It is just an open source project. For small projects you can directly use the Kubernetes, but when you're developing something, then you need something to run in your system, that is actually brought by minikubes, using the minikubes that is under this Kubernetes only. Small projects inside the Kubernetes like minikube and mini Kubernetes and K3s. K3s is a distributed version, like a small version of the Kubernetes that is actually helping the developers to develop their application, deploy inside the Kubernetes. These are the development one. There is a something called as production, where actually your users are using it. Okay, let me tell you. Uh, in the production version, like in the Linux you have Ubuntu, you have the CentOS, you have the Amazon Linux. These are actually built on top of the Linux is open source, on top of which you have the Ubuntu, CentOS and Amazon Linux, lot of things like this. Kubernetes is open source, and there are a lot of distributed Kubernetes that are available. The first one goes like the EKS by the Amazon, the Elastic Kubernetes Service by the Amazon, and you have the OpenShift from the Red Hat, Tanzu, Action. There are a lot of things. In the staging and the pre-production server, there is a set of things like as mentioned, OpenShift, Ranger and Tanzo, EKS, AKS, GKS, DKE, like the Google is also providing, Azure is also providing, Amazon is also providing such Kubernetes service, and you can able to use it for the production one. For the development you don't require huge things. For the production you require huge things, you have to pay for such things. And this is all about the container orchestration and the Kubernetes. Thank you.